Hey guys, welcome back to my channel, and in today's video we are going to solve one more LeetCode question, that is question number 100, same tree. This is an easy level question and it has been asked by so many companies, especially in these last 6 months. So let's see what this question is all about and how we can solve this question. So in this question we are given two binary tree roots, that is P and Q, and we have to write a function to check if they are same or not. So two binary trees are considered same if they are having identical structure and the nodes have the same value as well. So if we see in this example P and Q, we can see that the structure and values both are same, and that's why the output is also true. If we see example number 2, then we can see that structure is different even though the values are same, right? See this diagram in which the structure is different but values are same. That's why the output is false, because we are saying they are same only if the structure as well as the value both are identical. So, and in third example, the structure is same but the values are different, right? That's why the output is also false. So how we can solve this question? So let's see how we can solve this question using this example. So this is the same example, and in this example we can see that these two trees are given where we need to check whether they are identical or not. So firstly, let's traverse this tree and check each and every node and the values, and then we will come to a conclusion whether they are identical or not. So for that we can take two approaches. Firstly is recursive and iterative. So for now let's focus on the recursive approach. So in this approach what we are doing is we will firstly come up to the root nodes of both the trees. We are traversing the trees simultaneously, right? Then only we'll be able to understand that they are identical or not. So at this point we are standing at the root nodes of both the trees and we are saying check firstly they are null or not, because if they are null and if both of them are null, then we can say that they are already identical, right? Both will be having values equivalent to empty list, so these two are identicals. We can say it's identical, so return true. But if not, then check the value that the root nodes are having is equivalent or not. So firstly I will check that these two root nodes are having identical value. If yes, then move ahead and check the left node. So I will go and check the left node. Now again I am checking these two nodes at the same time, and these two are not null. They are having values and they are having same values, and that's why these two are also satisfying the identical condition, and I can proceed ahead and I will go to this right node. As we have already explored the whole left subtree because there is no further nodes, right? This was the leaf node, that's why now we are jumping to right node. And right node also we are going to do the same thing, that we are going to check if it's not null, then check the values are same. And if yes, then we know that all the nodes are satisfying the identical rules. And once we have already traversed the whole tree, we know that these two are identical and had never returned false or had never negated any of the conditions. That's why we can return true. So we will return true. So now I explained that we traverse the tree. But when we are going to code this solution, we are going to code the solution in two ways. Firstly, we will take the recursive approach, and after that we will be taking the iterative approach. Both the recursions are kind of same, but the methodologies are different, and we will look into it how they are different. So let's directly jump to code. So firstly, let's code the recursive approach. So let me just write it down there. And what I'm saying is, firstly check if not P and not Q. what this is checking, that they are null. If both of them are null, in that case return true, right? And if not, then check if not P, if any one of them is empty, right? That is also a condition where if any one of them is empty and one is having a value, that means we are not having identical trees, the structure is different, right? This means that the trees are not same, so that's why we are checking this condition as well. So if not P or not Q, or if they are having values, that is P dot val is not equivalent to Q dot val, any one of these conditions is true, in that case return false. So now two of the conditions are checked, and if these conditions are checked, then what's left? Then we need to check further nodes, right? So for that, what I'm saying, recursively call the same function for left and right node. So is same tree, and inside this what we are passing is P dot left comma Q dot left, and for right as well we are going to do the same thing, that is same tree, and again the same thing, P dot right comma Q dot right, and that's it. This is the whole solution, recursive solution. Now let's try to run this and check if it's work, which I think it's working. So we can see that this is accepted. So this was the recursive approach. Now let me show you the iterative approach as well. In iterative approach, what we do is we will put this whole conditional thing inside a function just to concise our code. So let's keep it check similarity, and inside this simply put these two conditions and return true at the end. Okay, so this is transformed now, and P and Q will be coming like this. Now how we are going to call this question? We are going to create a queue. So once we create a queue, inside this what we are saying, put P comma Q comma right, and once this is done, run a loop while this Q is there. Now what we are doing, P comma Q is equals to Q dot pop left, and simply check, if not check similarity. So in this function that we created, we are calling this function that we created inside this loop, and what we are saying, just check if it's returning false, because if it's returning false, in that case we need to return false. But if it's not returning false, then simply update our queue with P dot left comma Q dot left, and also with the right subtree or right child node, P dot right comma Q dot right, and this is it, because at the end what we will be doing, we will be returning true, and this was the whole. Here we need to add one more condition, that is if P is there, right? If value is there, then only we will be checking and updating our queue. Now let's try to submit this, and yes, we can see that this is also accepted. So this was the simple iterative approach, and both the approaches, that is recursive and iterative, are having same time and space complexity, that is big O of n, because if we see this whole approach, whether it's recursive or iterative, at the end we have to travel these two trees completely. So that's why the time complexity is going to be big O of n, where n is the number of node, and we are traveling through these trees and we are visiting every node in order to check the values are identical or not, right? And space complexity for recursive is going to be big O of n, because recursive approaches uses stack, right, for recursive calls. So in worst case scenario, there can be n calls and the size of the stack will be n. So the space complexity for recursive approach is big O of n. And for iterative approach, as we have already seen, that we created a deck, and for that we needed big O of n space. So that's why we created a data structure and we are using it, and it is going to occupy n space and time complexity will be same for both the approaches, only the way we are coding up the whole solution is different. So I hope this video was helpful for you all, and if you really find it helpful, then you can like this video, subscribe my channel, and I will soon come up with more such questions. Till then, keep messing with algorithms, and thanks for watching.